Let's do one example for angular momentum and angular impulse. Problem 178. In this problem, we have this freely rotating bar, which these two masses are connected to it with these two light bars. And at the beginning, everything is at rest, and we start to apply this moment, which is equal to 2 Newton meter, and it is constant. We're going to apply this moment for 5 seconds. And the question is, what's going to be the angular velocity of the system after 5 seconds? Okay. So I'm going to use angular momentum and angular impulse equation. So the beginning is 1 when t is equal to 0, and by 2 I mean when time is equal to 5 seconds, right? I'm going to use linear angular momentum equation between 1 and 2 based on the equation which we derived it in the previous video. And also I'm going to call this this point O, HO2 minus HO1 is going to be equal to integral from 1 to 2 sum of the moments that we have about point O dt. And time is going to go from 0 to 5 seconds, right? At the beginning, nothing is moving, so the velocity of both of them is 0. So mass times velocity times r is going to be equal to 0. So there is no angular momentum. And at the end, let's say after 5 seconds, everything is going to rotate with angular velocity of omega about this axis. In that case, any of these masses are going to move with the velocity of r times omega, right? Which r is equal to 0.4 meter. So the velocity is going to be r times omega. And angular velocity is going angular momentum is going to be mass times velocity times r, or r cross velocity times mass. So r is in this direction, velocity is perpendicular to it, the cross product of them is going to be in the z direction, right? And the moment is in the z direction as well. So everything is in the z direction, so I can just eliminate that z direction from both sides and write everything as scalars. So HO is going to be each mass times velocity times r. And because we have two masses, we are going to have two of them. So I'm going to have 2 times r times mass times velocity, which is going to be r omega for both masses. This one is r omega and this one is r omega 2. And 2 means, the first 2 means we have 2 of them, right? So it's going to be equal to integral from 0 to 5, and m is equal to 2 dt. Integral of 2 is going to be 2 times t, from 0 to 5 is going to be 2 times 5, 10. So from here, 2 times r squared, and r is 0.4, times mass, which is 1.2, times omega is equal to 10. And from here we can find omega. Omega is going to be equal to 286.0 radian per second.